Rajadhani Institute of Engineering and Technology. Engineering the future.
This calendar is a calendar actually modified form. Original calendar was called the Julian calendar. Julian calendar modified the Gregorian calendar like Leap year has one extra day. Leap year has got one extra, that is February 29. Why is that? Earth so leap year extra 1 by 4 times. Earth actually sun is time 365.25. 365 1 by 4 days on actually Earth sun is okay. This time calendar 365.25 365.25 or 365 1 by 4 or 365 days and 6 hours. 24 divided by 4 is 6 hours. Calendar we hours at express year 6 6 6 6 24 hours 1 day extra 1 day from the 4th year allocate. Okay. This is leap year system. Leap year system form basics. We measure 365 days and 6 hours. Okay. What happened during the 16th century and 17th century? We know that there was Renaissance. There was a lot of new methods in Europe. So, three new measurement methods. Now, actually, accurate. Earth sun is 365 days, 5 hours, 48 minutes, and 52 seconds. Accurate 365 days, 5 hours, 48 minutes, and 52 seconds. 52 seconds is a special 52 seconds. National anthem. Yes, our national anthem 52 seconds in album national controversy. So now that we 52 seconds the round off is 5 hours and 49 minutes. 5 hours and 49 minutes. There is a disparity. Differences this is 365 days, 5 hours, 49 minutes. That is 365 days and 6 hours. What's the difference? 11 minutes. There is a difference of 11 minutes. Okay. So 11 minutes is 1 year. 11 minutes difference. 1 year 11 minutes difference. No, not big deal. 1 year 11 difference. But 100 years this becomes 1100 minutes. 400 years after 4400 minutes. And this is approximately equal to 3 days. This is approximately equal to 3 days. 1 year 11 minutes in a difference there is not a big problem. But every 100 years it becomes 1100. Every 400 years we have 3 days missing. Every 400 years we have 3 days missing. So this is a problem. That means our calendar is no longer accurate. So they needed to correct this. They wanted to correct it. So they needed to remove 3 days in every 400 years. So during every 400 years, they have to remove 3 days because we know in 400 years we have 3 days extra. So what they decided was 100th year. 100th year leap year. Leap year can define in multiples of 4. All multiples of 4 are leap year. Okay. So 100th year Julian calendar is leap year. Julian calendar is 100th year leap year. But here we have the 3 days removing. Power decided to 100th year leap year. 100th year leap year. 100th year February 29. Our okay. Because we will do some opportunity. We need to do something extra. And we have to 200th year. 1 day. 200th year leap year. Then 300th year. Leap year. So 1, 2, 3. 3 days removing. 400th year removing. And 3 days 400 100 years 1 day remove ചെയ്തു, 200 years 1 day remove ചെയ്തു, 300 years 1 day remove ചെയ്തു. Okay, so ഇപ്പോൾ നമ്മുടെ കാലണ്ടർ കറക്റ്റ്. ജൂലിയൻ കാലണ്ടർ ഗ്രിഗോറിയൻ കാലണ്ടർ തമ്മിലുള്ള ഡിഫറൻസ് ഇതാണ്. ജൂലിയൻ കാലണ്ടറിൽ എല്ലാ മൾട്ടിപ്പിൾസ്, all the multiples of 4 are a leap year. In Gregorian calendar, 100 is not a leap year, 200 is not a leap year, 300 is not a leap year, but 400 is a leap year. അതിനർത്ഥം ഇയർ 2000 ലീപ് ഇയർ ആയിരുന്നു, ബട്ട് ഇയർ 1900 ലീപ് ഇയർ അല്ല, 1800 ലീപ് ഇയർ അല്ല, 1700 ലീപ് ഇയർ അല്ല, പക്ഷേ 1600 ലീപ് ഇയർ ആണ്. അതിനകത്ത് എന്താണ് 100 വെച്ച് എൻഡ് ചെയ്യുകയാണെങ്കിൽ ആ ഇയർ ലീപ് ഇയർ ആണെങ്കിൽ കണ്ടീഷൻ എന്താണ് 400ന്റെ മൾട്ടിപ്ലൈ ആയിരിക്കണം. 400ന്റെ മൾട്ടിപ്ലൈ ആയിരിക്കണം. നേരത്തെ നമ്മൾ ലീപ് ഇയർ ഡിഫൈൻ ചെയ്യാൻ ഈസി ആയിരുന്നു. We just say any multiple of 4 is a leap year. But Gregorian calendar രണ്ട് കണ്ടീഷൻ ഉണ്ട്. മൾട്ടിപ്പിൾ ഓഫ് 4 ആയിരിക്കണം. ഇയർ 00 വെച്ച് എൻഡ് ചെയ്യുകയാണെങ്കിൽ അത് മൾട്ടിപ്പിൾ ഓഫ് 400 ആയിരിക്കണം. ഇയർ 00ലാണ് എൻഡ് ചെയ്യുന്നതെങ്കിൽ അത് മൾട്ടിപ്പിൾ ഓഫ് 400 ആയിരിക്കും. ജൂലിയൻ കാലണ്ടർ ഗ്രിഗോറിയൻ കാലണ്ടർ തമ്മിലുള്ള മെയിൻ ഡിഫറൻസ് ഇതാണ്. ഓക്കെ, സോ Julian calendar year 100 was a leap year, Gregorian year 100, 200, 300 they are not leap years. നമ്മൾ ഫ്യൂച്ചറിലേക്കുള്ളത് കറക്റ്റ് ചെയ്തു. ഇത്ര നമ്മൾ ചെയ്തതെന്ന് വെച്ചാൽ എല്ലാ 400 ഇയേഴ്സും 3 ഡേ എക്സ്ട്രാ വരുന്നുണ്ട്. ആ പോയിന്റ് അതായത് 16th സെഞ്ചുറിയിൽ നിന്ന് ഫ്യൂച്ചറിലേക്കുള്ള കാലഘട്ടമെല്ലാം നമ്മൾ കറക്റ്റ് ചെയ്തു. പാസ്റ്റിലുള്ളതോ നമ്മൾ ഓൾറെഡി 1600 ഇയേഴ്സ് ഇതുപോലെ സെലിബ്രേറ്റ് ചെയ്തു. പാസ്റ്റിലെ കുറേ എക്സ്ട്രാ ഡേയ്സ് ഉണ്ട്, അത് നീങ്ങും. ഓക്കെ, അപ്പോൾ അതിന് വേണ്ടിയിട്ട് ഇതൊരു ടെക്നിക്ക് യൂസ് ചെയ്തു. എന്താണെന്ന് വെച്ചാൽ ഇതിൽ കുറെ കോൺട്രവേഴ്ഷ്യൽ പീരിയഡ്സ് ഉണ്ട്, പക്ഷേ പോപ്പുലർലി അക്സെപ്റ്റഡ് ആയിട്ടുള്ള ഡേറ്റ് ഉണ്ട്. ദാറ്റ് ഈസ് 1752 September 2. 1752 September 2 ആയിട്ട് 2. This was the last day of the Julian calendar. This was celebrated as the last day of the Julian calendar. Okay. And they celebrated the next day as 1752 September 14. Okay. In the particular നാളെ 13th സെലിബ്രേറ്റ് ചെയ്യുന്നതിന് പകരം ഇവരെ നാളെ 23 24 സെലിബ്രേറ്റ് ചെയ്യും. അതുപോലെ ഒരു ദിവസം സെപ്റ്റംബർ 2 ആയിരുന്നു, നെക്സ്റ്റ് ഡേ സെപ്റ്റംബർ 14. ഓക്കെ, പാസ്റ്റിലേക്കുള്ള ഡിസ്പാരിറ്റീസ്. ഓക്കെ, ബിക്കോസ് ഓഫ് അവർ error calculation we had a problem with the past year 1600 years. In order to correct all that, we skipped a lot of days and come to September 2 to September 14 directly. ഇതാണ് ഇവർ ചെയ്തത്. ഓക്കെ, സോ നമുക്കറിയാം യൂറോപ്പ് ഒരു ഇൻഡസ്ട്രിയലൈസ്ഡ് നേഷൻ. ബൈ 1752 യൂറോപ്പ് വാസ് എ മോസ്റ്റ്ലി ഇൻഡസ്ട്രിയലൈസ്ഡ് നേഷൻ. പീപ്പിൾ യൂസ് ടു വർക്ക് ഇൻ ലൈക് ഫാക്ടറീസ് ഫോർ മന്ത്ലി സാലറീസ്. പീപ്പിൾ യൂസ് ടു വർക്ക് ഫോർ മന്ത്ലി സാലറി. അപ്പോൾ ഈ മന്തിൽ എന്താണ് സംഭവിക്കുന്നത്? സെപ്റ്റംബർ അവർ ആക്ച്വലി 30 ഡേയ്സ് വർക്ക് ചെയ്യുന്നില്ല, പക്ഷേ 30 ഡേയ്സിന്റെ സാലറി ഉണ്ട്. 30 days actually വർക്ക് ചെയ്യുന്നില്ല. സെപ്റ്റംബർ 2 കഴിഞ്ഞാൽ പിന്നെ സെപ്റ്റംബർ 14 30 days ആക്ച്വലി വർക്ക് ചെയ്യുന്നില്ല, പക്ഷേ 30 ഡേയുടെ സാലറി അവർ മേടിക്കുന്നുണ്ട്. ഈ കോൺസെപ്റ്റിൽ നിന്നാണ് ആക്ച്വലി ക്യാഷ്വൽ ലീവിന്റെ കൺസെപ്റ്റ് വരുന്നത്. ക്യാഷ്വൽ ലീവ് എന്ന് പറഞ്ഞ കൺസെപ്റ്റ് ഫസ്റ്റ് ഒറിജിനേറ്റ് ചെയ്യുന്നത് ഇതിൽ നിന്നാണ്. ഇപ്പോൾ നമുക്കറിയാം ഏത് ജോലിയിലായാലും നമുക്ക് certain number of days ക്യാഷ്വൽ ലീവ് ആയിട്ട്. പിന്നെ വേറെ ചേഞ്ച് ജൂലിയൻ കാലണ്ടറിലേക്ക് മാറിക്കൊണ്ടാണ്. ജൂലിയൻ കാലണ്ടറിൽ ആക്ച്വലി ഏപ്രിൽ 1st ആണ് ന്യൂ ഇയർ ആയിട്ട് സെലിബ്രേറ്റ് ചെയ്യുന്നത്. ഏപ്രിൽ 1st ആണ് ന്യൂ ഇയർ ആയിട്ട് സെലിബ്രേറ്റ് ചെയ്യുന്നത്. അത് ഗ്രിഗോറിയൻ കാലണ്ടറിലേക്ക് വന്നപ്പോൾ അവർക്ക് ജാനുവരി 1st ആയിട്ട്. ഓക്കെ, അപ്പോൾ നിങ്ങളൊരു ഡേറ്റ് പർട്ടിക്കുലർ ഡേറ്റ് ന്യൂ ഇയർ ആയിട്ട് സെലിബ്രേറ്റ് ചെയ്തുകൊണ്ടിരിക്കുകയാണ്. വേറെ കുറേ ആൾക്കാർ നിങ്ങളോട് ഒന്ന് പറയാണ് ഇതല്ല ന്യൂ ഇയർ, ഇതല്ല ന്യൂ ഇയർ, വേറെ ഡേറ്റ് ആണ് ന്യൂ ഇയർ, നിങ്ങളത് ഫോളോ ചെയ്യുന്നു. ഇല്ല, നമ്മൾ ആഘോഷിക്കുന്ന ഡേറ്റ് തന്നെ നമ്മൾ ആഘോഷിക്കും. ഇപ്പോൾ ഒരു പരിപാടി ചെയ്തു, ഏപ്രിൽ 1st ന്യൂ ഇയർ ആഘോഷിക്കുന്നവരെ അവർ ഏപ്രിൽ ഫൂൾസ് എന്ന് വിളിച്ചു. അങ്ങനെയാണ് ഏപ്രിൽ ഫൂൾ എന്ന് പറഞ്ഞ കൺസെപ്റ്റ് വരുന്നത്. ഓക്കെ, സോ പക്ഷെ നമുക്കിപ്പോഴും ഫൈനാൻഷ്യൽ ഇയർ സ്റ്റാർട്ട് ചെയ്യുന്നത് എപ്പോഴാണ്? ഏപ്രിൽ 1st തന്നെയാണ് ഫൈനാൻഷ്യൽ ഇയർ നമ്മുടെ സ്റ്റാർട്ട് ചെയ്യുന്നത്. ഓക്കെ, സോ ഇതാണ് മേജർ ഡിഫറൻസ് ബിറ്റ്വീൻ ജൂലിയൻ കാലണ്ടർ ഗ്രിഗോറിയൻ കാലണ്ടർ. ജസ്റ്റ് സ്ലൈറ്റ് മോഡിഫിക്കേഷൻ അല്ല, ഒത്തിരി മാറ്റങ്ങൾ വരും. അതുകൊണ്ടാണ് നമ്മൾ ഇതിനെ സെപ്പറേറ്റ് കാലണ്ടർ ജൂലിയൻ ഗ്രിഗോറിയൻ എന്ന് പറഞ്ഞാൽ നമ്മൾ ജസ്റ്റ് ഇതിനെ സെപ്പറേറ്റ് ചെയ്യും. ഇതാണ് മേജർ ഡിഫറൻസ്. ഓക്കെ, ഒരു ജാനുവരി എത്ര ദിവസം ഉണ്ട്? ജാനുവരി 31 months days ഉണ്ട്, ഓഗസ്റ്റിന് 31 days ഉണ്ട്. ജൂലൈ ആക്ച്വലി ജൂലിയസ് സീസറിന്റെ പേരിലാണ് നെയിം ചെയ്തത്. ജൂലൈ ഇസ് നെയിംഡ് ആഫ്റ്റർ ജൂലിയസ് സീസർ. ഓഗസ്റ്റ് ഇസ് നെയിംഡ് ആഫ്റ്റർ Augustus Caesar. Julius Caesar's nephew ആയിരുന്നു Augustus Caesar. Julius Caesarന്റെ പേരുള്ള മാസത്തിന് 31 days വന്നു. Augustus Caesar പറഞ്ഞു എൻ്റെ മാസത്തിനും 31 days വന്നു. സിമ്പിൾ. അതുകൊണ്ടാണ് നമുക്ക് ജൂലൈയിലും ഓഗസ്റ്റിലും 31 days വെച്ചിട്ടുണ്ട്. എംപറേഴ്സിന്റെ ഈഗോ സാറ്റിസ്ഫൈ ചെയ്യാൻ വേണ്ടി. അതുപോലെ ചില മന്ത്സ് അവരുടെ ദേവന്മാരുടെ പേരാണ്. ജാനുവരി അവരുടെ ദേവന്മാരുടെ പേരിലാണ് പേരിട്ടേക്കുന്നത്. അതുകൊണ്ട് അവർക്ക് ചിലതിന് ഇമ്പോർട്ടൻസ് കൂടി 31 days കൊടുത്തു, ചിലതിന് 28, ചിലതിന് 30. Okay, that's the reason why we have an even calendar, but our calendar is how it is. We have to follow that. Okay, so this is about the origin of our calendar. Remember, magic shows. One guy will walk into the midst. He'll just pick you up. Another birthday, and then will make him. Okay, you will take correct day and okay. Number next our topic and tackle. That's solve it. Okay. Our topic and tackle. Okay. Now before that, what is the first day of the week? What is the first day of the week? Sunday. Monday. It's Monday. First day of the week is Monday. Okay. So this is actually where is this calendar originated? Gregorian calendar. No, I don't want the country, just general region. Europe. It was originated in Europe. Okay. Gregorian calendar originated in Europe. What is the major religion in Europe? Christianity is the major religion in Europe. According to Christians, Muslims and Jews, the same thing is God created the world in 6 days and rested on the 7th day. God created the world in 6 days and rested on the 7th day. Okay. So according to Christians, this day, God's day is Sunday. Christians celebrate God's day as Sunday. Jews celebrate God's day as Saturday. Muslims celebrate God's day as Friday. But this calendar was originated in Europe. So according to Christian belief, first day of the week is Monday, and last day, 7th day of the week, the day God rested, that is Sunday. So first day is actually Monday. First day of the week is actually Monday according to the Gregorian calendar. This will be a Monday, first day of the first month of the first year. First January 01. This should be a Monday according to the Gregorian calendar. Okay. Now we have 300. I have said that we have 365 days in particular year. How many weeks are there in 365 days? 365 divided by 7. 365 divided by 7, that is 52 weeks. Plus there will be one remainder. So 52 weeks and 1 day. 52 weeks and 1 day extra will be there. Next, what about leap year? 366 days. So we will have how many weeks? 52 weeks and 2 extra 1, that is 2 days extra it will have. Okay. So we have 1101. First day, 1st January 01. Next January date is 31/12/01. Last day of the year, 31st December of the first year. Okay, so I told you we have 52 weeks and 1 day extra. 52 weeks and 1 day extra. So just before 31st is the last day. 31st is the last day. So just before the last day, 52 weeks are completed. Last day to 52 weeks completed. Okay. So 31st to the last day is Sunday. Last day will be Sunday. 52 weeks are completed. Fully complete means 31st to the Sunday. So 31st is the Monday. 31st may be Monday. Next we have first day of the second year. First day of the second year. Which day is it? Tuesday. This will be a Tuesday because it's the next day after the 31st of December. What about 31/12/02? 52 weeks are completed and next day it will be again Tuesday because starting from Tuesday again will be completed up to Monday. Then the next day is Tuesday. So we again have Tuesday. Next year starting with Wednesday. We will start with Wednesday and we will end with end with Friday. This ends with Friday. Why? Because it's a leap year. Year 4 is a leap year. Doesn't matter before we start because an extra day comes after February. So when it comes to the end of the year, we actually should have Friday instead of Thursday, so that one extra day. Okay. So by taking this, we can say that last day is Friday. This is method for first 2-3 years. Maybe we can use this method, but for the years period, we can't use this method because we'll be calculating 1947 or 1958. By that time, we can't use this method. Definitely we can't. So here we are going to introduce a concept called odd days. Concept called odd days. Odd day. What do you mean odd one? Pick the odd one out. Odd means extra. Whatever extra one. We will have the exercise during our English. Like we will be given a certain number of words. Pick the odd one. Odd one means something that doesn't go into the group. Something that is extra. Okay. What is extra here? In 365 days, what is the extra day? That extra 1 day. Others is 52 weeks complete. We have one extra day. Next we have 52 weeks for leap year, 52 weeks and 2 days. These 2 days are called the odd days. So for a normal year we have 1 odd day. For the leap year we have 2 odd days. This is the most important concept we are going to learn in calendars. Any problem you do regarding the calendars will be doing calculation based on the odd days. So now here it is. First year, how many odd days are there? Normal year, so 1 odd day, 65 days, 52 weeks and 1 day. So we have 1 odd day. So what is the second year? 1 odd day. Third year, 1 odd day. Fourth year, 2 odd days. Because in the leap year we have 2 odd days. Okay. So now I'm given the question. I want to find the last day of the 4th year. I want to find the last day of the 4th year. So instead of doing this, what I do is I'll just add the number of odd days. 1, 2, 3 plus 2, 5. So I have, by the end of the year, I have 5 odd days. What is the 5th day? 5th day. Monday, Tuesday, Wednesday, Thursday, Friday. So 5th day is Friday. So I'm going to say 31, 12, 0, 4 is a Friday. It's a Friday. You will get the same answer. Okay, so this is how we use the concept of odd days. If we want to find a day, take the sum of odd days just before that day and add them and find the total number of odd days. If you get 2 odd days, that means which day? Tuesday. If it's 7, Sunday. But you will never get 7 odd days. You will get 0 odd days. I'll tell you that. So we did this calculation. We actually assume that we want to find the last day of the year. 31, 12, 10. We want to find the last day of the 10th year. Okay. Now, how many odd days are there? How many odd days are there? First year we have 1 odd day. Second year 2. Third year 3. Fourth year 2. That is 5 and 6, 7, 8, 9, 10. So for 10 years we will have, normal year we will have 10 odd days. Because of leap year we will have extra odd days. How many leap years are there in 10 years? 10 by 2. So we have 10 by 7, 10 by 4. We have 2 leap years in 10 years. We have 2 leap years in 10 years. So total number of odd days will be 10 plus 2. That will be 10 plus 2. 12 odd days. You will have 12 odd days. But if you want to find the number of odd days, just take the number of years, then divide it by 4. That will give you the number of years. Then take the number of years, then plus number of leap years. That will give you the total number of odd days. Because we have 1 extra day when it comes to a leap year. 1 extra odd day when it comes to a leap year. Clear now? Okay. So I have 12 odd days. 12th day on a day. So we only have 7 days. So we need to divide this by 7 and take the remainder. What is the remainder? 12 divided by 7. 4. 5. 12 divided by 7, remainder is 5. So actual answer is 5 odd days. So fifth day is again Friday. So answer is Friday. So when you get the number of odd days, that's above 7, always divide by 7 and take the remainder. So there you will get the actual number of odd days. Clear? Concept clear? Odd days which are the year in the case calculating. Okay. So next, what we are going to do is we are going to find out which day was our Independence Day. Okay. Independence Day. 15th August 1947. So 15th August 1947. Okay. So this is calculating number of odd days calculating. Number of odd days calculating. That is 15th August 1947 number. Extra odd days completed number calculating. So this calculation is cost. Calculation is cost is the thing right here. हम लोग इकट्ठा एक्सप्लेन है 1947 कारण 1947 completed है 1947 completed है हम लोग इकट्ठा ईयर ഇതിനെ തൊട്ട് മുമ്പ് കംപ്ലീറ്റ് ആയില്ല കംപ്ലീറ്റഡ് ഇയർ ഏതാണ് കംപ്ലീറ്റഡ് ഇയർ ഏതാണ് 1946 സോ 1946 ആണ് നമ്മൾ കാൽക്കുലേഷൻ ഇവിടെ സ്റ്റാർട്ട് ചെയ്യുന്നത് എന്നുവെച്ചാൽ 1947 കഴിഞ്ഞിട്ടില്ല 1947 ഓൾമോസ്റ്റ് മിഡ്വേ ആയിട്ടുള്ളൂ ഓഗസ്റ്റ് വരെ ആയിട്ടുള്ളൂ ഓക്കെ സോ ഫസ്റ്റ് വി കാൽക്കുലേറ്റ് 1946 ഓക്കെ നൗ ഇതിനെ കാൽക്കുലേറ്റ് ചെയ്യണമെങ്കിൽ നമുക്ക് ഇതിനെ 1946 എടുത്ത് ഡിവൈഡ് ബൈ 4 എടുത്തിട്ട് ചെയ്യുന്ന അഗൈൻ ഒത്തിരി ടൈം നമ്മൾ അതിന്റെ shorten ചെയ്യാൻ പോകും no so we have ഓരോ 100 years 200 years നമ്മൾ കാൽക്കുലേറ്റ് ചെയ്യാൻ പോകും so 100 years 100 years എത്ര days ഉണ്ട് 100 plus 100 divided by 4 25 പക്ഷേ ഒരു പ്രശ്നമുണ്ട് 100 year leap year according to നമ്മുടെ Gregorian calendar 100th year is not a leap year. Julian calendar Gregorian calendar modify ചെയ്തപ്പോൾ നമ്മൾ extra 3 days remove ചെയ്യാൻ വേണ്ടി 100th year 200th year 300th year മാറ്റി. So 100th year leap year. So won't be 25, will be 24. So I have a total of 124 days. 124 divided by 7 remainder. What's the remainder? 5. 5 is the remainder. 5 is the remainder. 24 divided by 7. So every 100 years we have 5 odd days. Every 100 years we have 5 odd days. Okay. Now to start. Next we will do it for 200 years. For 200 years how many odd days will be there? 200 plus 200 divided by 4. Again we have to neglect the 100th year and 200th year. So it will be 100 plus 200 plus 48. We can take the odd days that way or we already found there's 5 odd days in 100 years. We already found there is 5 odd days in 100 years. Next 100 years nothing has changed. Same 100 years. So how many odd days will be there? 5 into 2. There will be 10 odd days. 5 into 10 odd days. Total, we are taking for the first 200 total 200 years, so there will be 5 into 10 odd days. 10 divided by 7 remainder. 10 divided by 7 remainder 3. So we have 3 odd days. So for the first 100 years we have 5 odd days. For the first 200 years we have 3 odd days. Next we will calculate for 300 years. How many odd days are there in 300 years? 5 into 100 years there are 5 odd days. So in 300 years 5 into 3 15 odd days. 15 odd days. 15 divided by 7 remainder is 1. 15 divided by 7 remainder is 1. So in 300 years we have 1 odd days. In 100 years we have 5 odd days. In first 200 years we have 3 odd days. In first 300 years total we have 1 odd day. Next 400 years. 400 years number of days is 5 into 100 years, that is 5. So in 400 years, there will be 5 into 4 plus 400 year is a leap year. We only remove that one day for the 100 year, 200 year and 300 year. 400 year is still a leap year. So we should add that plus 1. So 5 20. 20 plus 1, 21. And 21 divided by 7, remainder 0. Because 21 is perfectly divisible by 7. So the remainder is 0 voltage. So in first 100 years, we have 5 voltage. In first 200 years, we have 3 voltage. In first 300 years, we have 1 voltage. In the first 400 years, we have 0 voltage. So what happens after 400 years? 0 voltage means at the end of 400 years, the calendar will reset itself. Then it will start again. Between 1 and 400, there are 0 voltage. Means next year, start of the next year will be the same as that of the first year. Okay, after 400 years, every 400 years, the calendar completely resets itself and it follows the same pattern. So after 400 years, we have 0 days. After 800 years, we have 0 days. After 1200 years, we have 0 days. 1600 years, we have 0 days. After 2000 years, we have 0 days. Clear? Okay. So now we have the year 1946. We have the year 1946. Okay. Now in entire 400 year the numerically 2000 ആണ് പക്ഷേ നമുക്ക് കാലണ്ടറിന്റെ കേസിൽ ഒരിക്കലും ഫ്രണ്ടിലേക്ക് വന്നിട്ട് ബാക്കിലേക്ക് കൗണ്ട് ചെയ്ത് പോകാൻ പറ്റില്ല. നമ്മൾ തൊട്ട് മുമ്പ് കംപ്ലീറ്റ് ചെയ്ത 400 ഇയർ ഏതാണെന്ന് നോക്കുക. 1600. So I'm going to split this and write it as 1600. Remaining in 1900 minus 1600. Remaining is 346. Split this again. 300 plus 46. കാരണം നമുക്ക് already 100, 200, 300 years ഉള്ള voltage നമ്മൾ already കണ്ടുപിടിച്ചിട്ടുണ്ട്. 5, 3, 1. Okay. 1600 എത്ര voltage ഉണ്ട്? 0. 1600 നമുക്ക് 0 voltage ഉണ്ട്. 300 years എത്ര voltage ഉണ്ട്? 300 years we have 1 voltage. So 300 we have 1 voltage. 46. അതാണ് സാധാരണ ഇത് കണ്ടുപിടിക്കുന്നത്. 46 plus 46 divided by 4, 11. 46 divided by 4, 44. 11 4, 44. Therefore, 46 years we will have total voltage of 46 plus 46 divided by 4, that is 11. So, 46 plus 11, 57. We will have 57 voltage. Because of 300 years we have 1 voltage. Because of 46 years we have 57 voltage. So total number of voltage is 57 plus 1. Here because of 1600 we have 0 voltage. Because of 300 years we have 1 voltage. Because of 46 years we have 46 plus 11, that is 57. So total number of voltage because of here is 57 plus 1 plus 0. 0 something number of years. So answer is 58. Can we have 58 voltage? No. So we should divide 58 divided by 7. So 58 divided by 7. Remainder is, so 7, 8, 56. So 56. So remainder will be 2. So we have 2 voltage in the end until the end of 1946. Okay. But the problem is not over because we want to find 15th August 1947. So year, completed year 1946 varana completed years. Completed years varana in the months. Now we have a problem of months. Okay. Either then copy 100 years 5 days, 200 years 3 days, 300 years 1 day, 400 years 0 day. Okay. നമ്മൾ മനസ്സിലേക്ക് കൺസിഡർ. Okay. So we are January, February, March, April, May, June, July, August, September, October, November and December. 28. 28 plus 3 is 31. So remainder is 3. So there are 3 odd days. 3 odd days is obtained by 31 divided by 7 remainder. That is 3. What about February? How many days are there? Normally 28. 28 divided by 7 remainder 0. So we have 0 odd days in February. If it's a leap year, we have 29 days. So how many odd days will be there? 1. So we have 0 or 1 odd days in February, depending on whether it's a leap year month. Now March, how many days? 31. So number of odd days is 3. April, number of days is 30. 30 divided by 7 remainder is 2. May, again 31 days, so 3. June, 30 days, so 30 divided by 7 remainder 2. July, 31 days, so 3. August, again 31 days because of August season, so we have 3. September, 2. October, 3. November, 2. December, 3. So this is the number of days according to the months, according to how many months that we have. Okay. So we have 1946. We have finished with the problem of years. Completed years we have finished, and we have found that there are 2 odd days. Year problem we have finished, and we found that there are 2 odd days. Okay. Now we need to tackle the problem of months. Okay. Which is the completed month? Is August completed? No. The month that is completed is July. July, up to July, it's completed. Next year, 1947 is the year. Is it a leap year? No, because it's an odd number. We don't even need to check. It's definitely not a leap year. So, number of days in February will be 0. What is there for leap year? This is there for ordinary year. So, we have 0 days in this particular case. So, we'll take 3 plus 0 plus 3, 6 plus 2, 8 plus 3, 11 plus 2, 13 plus 3, 16. So for months we have 16. Because of month we have 16 odd days. Because of months we have 16 odd days. Can we have 16 odd days? No, 16 we only have below 7. So 16 divided by 7 remainder 2. We have remainder of 2. Again we have 2 odd days. Next we will just look at the date. Look at the date. Date is 15. So date is 15 divided by 7. 15 divided by 7. Remainder is 1. 1 odd day. Okay. So here we have found 3 things. First, because of year, how many odd days are there? Because of months, how many odd days are there? Because of the date itself, how many odd days are there? We found all 3 things. Now we are going to add them. Because of year, how many odd days are there? Here we have 2 odd days. Because of month, how many odd days are there? 2. Again, 2 odd days. Because of day, how many odd days are there? 1. So we have total of 5 odd days. Total of 5 odd days. 5th day is which day? Friday. So our Independence Day was on a Friday. This is how we calculate. This is how we find the day. Take the completed year, take the completed month, take the number of days, find the number of odd days, just add them and you will get the answer. Clear? Any doubts? Okay, next, find the Republic Day. When is the Republic Day? 26 January 1950. Okay, find the Republic Day. Which day was it? Thursday. Any other answers? Okay. This is 26 January 1950. Which is the completed year? Which is the completed year? 1950 is not completed. 1950 is just started. So completed year is 1949. So completed year is 1949. How are we going to split this? How are we going to split Take a multiple of nearest multiple of 400 because every 400 years the calendar resets itself. We have 0 odd days at the end of 400 years. Every 400 years. That's why we are splitting it into multiples of 400. So nearest multiple of 400 completed one is 1600. 2000 is not yet completed. Completed multiple is 1600. Next, what is remaining? 349. And plus 300 plus 49. Okay. How many odd days in 1600 years? 0. Any multiple of 400 we have 0 odd days. Next, in 300 years, how many odd days do we have? 1 odd day. In 300 years, we have 1 odd day. In 49 years, 49 plus 49 divided by 4. 49 divided by 4 is 12. So there are 12 leap years. 49 regular years and 12 leap years. So this will be 61. So total number of odd days. Total number of odd days because of the number of years is 0 plus 1 plus 61. So we have 62 odd days just because of the number of years. Okay, 62 odd days means 62 divided by 7. 62 divided by 7 is remainder is 63 is a multiple of 7. So 6 odd days. So we have 6 odd days. We have 6 odd days because of the purely because of the number of years. Next, we look at the month. Month is January. Is January completed? No, because so we don't need to take anything because if not even the first month is completed. Then we just look at the number of days. 26. 26 divided by 7. Remainder is 5. Remainder is 5. So we have 26 January 1950 because of the year 1950 we have 6 odd days. Because of the month we don't have the odd days because 1 month is not completed. So 0. Next number of days 5. So 6 plus 0 plus 5 we have 11 odd days. Again we can't have anything more than 6 odd days. So 11 divided by 7. Remainder is 4. We have 4 odd days. There is Thursday, Monday, Tuesday, Wednesday. Fourth day is Thursday. We have our public day was on Thursday and Independence Day on Friday. Then the questions 1, 2, 3, 4, 6 and 8. 1, 2, 3, 4, 6 and 8. Question number 1, what is the answer? Option B, Saturday. Option B, Saturday is the answer. So today is Monday. Today is Monday. After 61 days it will be okay. So 61 divided by 7. What's the remainder? 5. 5. Fifth day is Friday. But they asked not the 61 days after 61 days. So they didn't ask 61st day, they asked after 61 days. So 61st day will be Friday. One day later it will be Saturday. So answer is option B, Saturday. Okay, they've asked at what is the 61st day? Your answer would have been Friday. Today they've asked after 61st day. So Saturday. Question number 2. 18th October 2015. It is Tuesday. That's right, Tuesday. Okay. Here again, what more? Most of the mistakes I see is we have to take 2049, not 2016. Here the date is 18th October 2015. We have to take 2049. Complete. The year which is multiple of 400. Completed close. This is little close side complete the 400 to multiply that. 2000. 2000 is the closest multiple which is of 400 which is completed. Okay. So this is 2000 plus 49. 2000 2000, we have how many odd days? 0 odd days. Every multiple of 400 will have 0 odd days. So we have 0 odd days. 49, we have 49 plus 49 divided by 4. 49 divided by 4 is 12. So we will have 49 plus number of leap years in 49 is 12. So 49 plus 12, that will be 61 odd days because of the number of years. So maximum day is 61 divided by 7, and that will be 5 odd days. We have 5 odd days because of the number of years. Okay. Now we look at the month. We completed the year. Now we look at the month. October. October is not completed. So we need to look up to September, and we need to look up to September. And so this 2049 in India, no sorry, 2050 in India. No, because it's not a multiple of 4. It is not a multiple of 4. So we have 0 days in February. We have 0 days in February. So 3, 6, 8, 11, 13, 16, 19, 21. So we have 21 odd days because of the month. 21 odd days up to September end. So total number of odd days is 21 divided by 7, and is 0. So we have 0 odd days because of the month October. Now date 8. Now we have the date 18. So 18 divided by 7, and is 4. So we have 18 October 2020 because of the year. Because of the year we have 5 odd days. Because of the month we have 0 odd days. Because of the day we have 4 odd days. So total number of odd days is 5 plus 0 plus 4, that is equal to 9. 9 we can't have 9 odd days. So 9 divided by 7, remainder is 2. Second day. Second day is first day is Monday. Second day is Tuesday. So answer is Tuesday. Okay. Clear? Always take the completed year, completed month, then take the days. Okay. Now, next question. Which of the following is a leap year? D. Okay, look at option A, 1146. What is the divisibility rule for checking multiple of 4? Last 2 digits. Just look at the last 2 digits, whether it's a multiple of 4, then that particular number is a multiple of 4. 46 is it a multiple of 4? No, we know that 44 is a multiple of 4. So first option is not the answer. Second option, 1254. No, because 52 is the multiple of 4. Next, 2100. It's a multiple of 4, but in Gregorian calendar, if it ends with 00, then it has to be a multiple of 400, not 4. So 2100 is not a multiple of 400. Option D, 1128. 28 is a multiple of 4. So the only year which is a leap year is option D. Okay. Question number 4. Option. Okay. Now, question number 4. How many days are there? How many days could be in K weeks and K days? How many days could there be in K weeks and K days? And K can have the value of 1 to infinity. Any value we can have K weeks and K days. K can take any value from 1 to infinity. Okay. So here, let's assume that it is 1 week. Let's assume that it is 1 week and 1 day. 1 week, 1 day. 1 week, how many days are there? 7. 1 day plus 1. 7 plus 1, 8. Any value you put for K, you will get 7K plus 1K. If it is K weeks, then means there is 7K days. If it is K days, means there is K days. So 7K plus K, 8K days. Whatever you get will be a multiple of 8. Look at the options, which is a multiple of 8. Only option multiple of 8 is 96. So answer is option A, 96. Okay. Now, question number 6. Question number 6. Cannot start with which of the following. First day of the year cannot start with which of the following. We know that every 400 years the calendar resets itself. Every 400 years, calendar resets itself. So, if we need to check the first days of a century, we only need to look at 400 years. If we look at any 400 years, then everything else will be a repeated pattern of that 400 years. Okay. So, we take the 100 year first. 100 year. Which is the first day of the century? 1/1/2000. Is it the first day of the century? No. It's the first day of the last century. 1/1/2001 is the first day of the new century. First day of the 21st century is 1/1/2001, not 2000. Okay. So 100th year, when I say 100th year, it means I am telling the first day of the next year. So before, how many odd days are completed? How many odd days are completed in 100 years? We calculated. There are 5 odd days at the end of 100 years. 5 odd days at the end of 100 years. So the day which is at the end of the 100th year, the day which is at the end of the 100th year will be the 5th day. That is Friday. Now we want the first day of the next year, first day of the beginning of the century. So we want plus 1 day, that is the beginning of the next year. So it will be a Saturday. So after 100 years, next millennium will start with Saturday. Okay. Now we will look at 200 years. After 200 years. Okay. 200 years, how many odd days are there? 5 into 2 divided by 7. That is 3 odd days are there. So we have 3 odd days. So last day of that century will be 3rd day. That is Wednesday. Last day of that century will be Wednesday. Beginning of the next century will be plus 1. That will be Thursday. So we have Thursday as the beginning of the next century of 200 years. Next we will look at the 300 years. How many odd days are there in 300 years? 1 odd day. So it will end with 1 odd day plus 1. So second day is Tuesday. Second day is Tuesday. Now after 400 years. 400 years, how many odd days are there? 0 odd days. So next we will start with plus 1. So we will start with Monday. So we have centuries starting. So pattern of 400 years. We have completed. Anything else? Next will be Saturday, then again Thursday, then Friday, Tuesday, then Monday. This pattern will keep on repeating itself because the calendar resets itself after every 400 years. After 400 years, number of odd days is 0. That means calendar will reset itself every 400 years. Okay. So century can start with Saturday, Thursday, Tuesday, or Monday. So days it cannot start with can't start with Sunday, can't start with Wednesday, can't start with Friday. So Sunday, Wednesday, and Friday. Answer is option A. Option A is the answer. Here, just calculate the odd days and remember, first day of the century is not the 100th year, it's 101st year. First day of the century is next year, start of the next century. Okay. Any doubts? Clear? This question is clear. Okay. So we'll go to the next question. Which of the following 2 months in particular year will have the same calendar? Which of the following 2 months will have the same calendar? So they have asked about months. Now we need the number of odd days in months. We already calculated. How many odd days are there in January? There are 31 days. 31 divided by 7. Remainder is 3. So there are 3 odd days in January. February 0 or 1. March 3. April 2. May 3. June 2. July 3. August again 3. September 2. October 3. November 2. December 3. This is the number 4. 31 days means 3 odd days. 30 days means 2 odd days. 38 days means 0 odd days. Okay. Now they asked which of the following months in a particular year? Okay, so particular year means they have asked about a normal year. So we have to accept that this is a normal year and not a leap year. The generalized question, particular year. Most of the years are not leap years, most of the years are normal years. So we are going to take February to have 0 odd days. So I said that after 400 years calendar resets itself. Why does the calendar reset itself? Why is the calendar resetting itself? In terms of odd days. Because there is 0 odd days after 400 years, the calendar is resetting itself. So for 2 months to have the same calendar, between them they should have 0 odd days. If 2 months in between them they have 0 odd days, that means month will also start on the same day. Same way calendar is resetting, month can also reset within a same year. Okay. So here we are going to look at when will I get 0 odd days? Whenever the number of odd days is a multiple of 7, I will get 0 odd days. So here I have to look for when I will have the sum of as multiple of 7. So 3 not a multiple of 7, 3 plus 0 again not a multiple of 7, plus 3 6 not a multiple of 7, plus 2 8 again no, plus 3 11 no, plus 2 13 again no, plus 3 16 no, plus 3 19 again no, plus 2 21 21. At the end of September I have 21 odd days. At the end of September we have 0 odd days. That means this calendar will start resetting after September. So it starts from January. October will start again the same pattern as January, because between January and October there are 0 odd days. So between January and October there are 0 odd days. It's not just 400 years, between some years may be having the same calendar. If January 1st of the year starts on the same day, then those 2 years will be having the almost exact same calendar. So in order to find that, just check that between those 2 years, do you have 0 odd days? If you have 0 odd days, that means those 2 years will be identical. Clear? That's how we use the odd days. Okay. Now next we'll move on to our next topic, that is clocks. Okay, so for clocks, which type of clock do we have? What are the different types of clocks? Analog and digital. Okay, but here we'll be dealing with analog clock and analog clock only. Or analog clock, 12 hours a month, goes around twice a day, one day is complete. We'll be dealing with our analog clock a lot in this type of questions. Okay, so we have a few types of questions mainly appearing. First one is mirror image. Right. Second one is angle based. Third type is coincidence of hands. Fourth type is current and decurrent. Okay. These are the main four categories of types of questions that we will be encountering in the clock type of questions. Okay. Now mirror image question. Okay, what is another? One guy is standing in front of a mirror. He is trying to get ready to go to the office. He looks at the mirror and he sees the time as 3:45. Sees the time as 3:45. Find the actual time. He is standing in front of a mirror and he sees the time in the mirror as 3:45. Find the actual time. 9:15. Sure. Okay. The guy sees the time in the clock as 3:45. What that means, the long hand will be pointing at exactly 45. 3:45 means the third hand will be pointing in the middle, not towards 4, because our hand moves as the minute hand also moves. It doesn't just jump from 1 to 2 when it goes from 1 p.m. to 2 p.m. It goes gradually along the minute hand. Okay. Now the mirror remains. Exact opposite of this. By that, this the exact opposite. So this hand will point towards this side. This hand will point here. Our hand will come to here. So what's the time? 8:50, not 9:15. 8:50. 8:50 is the time. We need to visualize the clock and then convert it. Okay. Now tell me, the answer. Again, so now you have understood, most of you can't trust your visualization because you are going to the wrong answer. But if we are trying to draw the figure for every question, it will be a little bit time consuming. Okay. So here, what is 345 plus 850? 345 plus 850. 3 plus 8, 11. 45 plus 15 is 1 hour. So 11 plus 1. 12. What is 520 plus 640? 5 plus 6 is 11. 20 plus 40 is 12. So whatever time you get, just subtract the time from the 12 and you will get the 12 rupees. Whatever time you get, subtract it from 12 and you will get the 12 rupees. Okay, so what is the mirror image of 720? Mirror image of 720. 720 mirror image is 12 minus 7 divided 20, so it will be 440. Will be 440 because when you add that you will get 12. So almost 11, 20 plus 40, 1, 11 plus 1, 12. Okay, so you don't have to draw the block, just remember 12 minus whatever is given, that will give you the mirror image. Clear? Next we will deal with how to find the angles. How to find the angles in a particular clock. Okay, question is this. The clock is showing a time of 7:20. The clock is showing a time of 7:20. Find the angle between the hands. Clock is showing a time of 7:20. Find the angle between the hands. When the how much time does the our hand take to complete 360? How much time is taken by our hand to complete 360 revolution? That is one total revolution. How much time is taken by the our hand to complete one total revolution? 12 hours. Our hand takes 12 hours to complete 360. That is one full revolution. Okay. So what's the time taken for completing 1 hour? What's the angle moved for 1 hour? 360 divided by 12. That's equal to 30 degrees. So the upper hand moves 30 degrees for every hour. 1 hour moves 30 degrees. Okay, what about minute hand? Minute hand. How much time does it take to cover 360 degrees? 60 minutes. It covers 360 degrees in 60 minutes. So 1 minute, it goes 360 divided by 60, that is 6 degrees. 1 minute goes 6 degrees. Okay. Now, does the upper hand stay stationary when minute hand is moving? No, upper hand moves along with the minute hand. So 1 hour it means it moves 30 degrees. Okay, so in 60 minutes it will move again 30 degrees. Simply converted 1 hour 30 degrees. So 60 minutes 30 degrees. So 1 minute 30 divided by 60. That is half degree. The upper hand moves 30 degrees for 1 hour, half degree for every 1 minute, and minute hand moves 6 degrees for every 1 minute. Okay, now we look at the angle for 720. So minute hand will be pointing at exactly at 20. It will be somewhere between 7 and 8. Okay. So we will take this as the reference line. So from here, starting, how much will the minute hand move? Our hand move. First the our hand, how much will it move? It's moved 7 hours. It has definitely moved 7 hours because our time is 7:20. So for our hand, we have 7 hours. 7 hours, 1 hour, how much degrees does it move? How many degrees does it move in 1 hour? 30 degrees. It has definitely moved 7 hours. So what? 7 into 30. 210 degrees it moves because of the hour level. Next, we have to also consider the minutes. because our hand resistance to it, okay, it will move. So we have moved for 20 minutes. So how much does it move for? 1 minute. 1 minute. 1 minute. How much does the our hand move? Half a degree. It moves half a degree. So it will be 10. So total moved by the our hand will be 220 degrees. 220 degrees is the total angle moved by the our hand. So this angle is 220 degrees. Okay. Next we will look for the minute hand. For minute hand we only have to consider the minutes. So here minutes is 20. 20 into distance moved every minute is 60. So 120 degrees. So question is what is the angle between them? What is the angle? This is 220 degree. This is 120 degree. This is 120 degree. So angle between them is this angle is 220 minus 120. 100 degrees. 100 degrees is the answer. Draw the clock and solve this problem, or we can find a general expression from the what we have derived. We are going to find a general expression from the formula that we have derived. So we have h hours and m minutes. Okay, we have a general expression, so we are going to take h hours and m minutes. Okay. 1 hour, how much does it move? 1 hour for our hand. First we are going to consider for our hand. 1 hour, how much does it move? 30 degrees. 1 hour it moves 30 degrees. So it will be h into 30 plus 1 minute. How much does it move? 1 minute. 1 minute. Half a degree plus half. How many number of minutes into half? This is the total distance moved by the our hand in h hours and m minutes. So we write this as 30h plus half m. 30h plus half m. So this is the distance moved by the our hand in h hours and m minutes. Okay. Next we will consider the minute hand. Minute hand. So what is the distance moved by the minute hand? 1 degree. How much does it move? 6 degrees. 1 minute it will move 6 degrees. 1 minute it will move 6 degrees. So distance moved in m minutes is m into 6. That is 6 m. This is the distance moved by our hand and the minute hand. Now we have to find the angle between them. Angle between them. So we denote this angle as theta. We denote this angle as theta. Theta is equal to distance moved by the our hand minus distance moved by the minute hand. Distance moved by the our hand is 30h minus plus half minute. This is the distance moved by the our hand minus distance moved by the minute hand. That is minus 6 seconds. That's equal to theta equal to 30h half minus 6. That is 5.5 minutes. This is the general expression for finding the angle between our hand and minute hand for h hours and m minutes. You can substitute any value for h and m and you will get the answer for theta. This is improper fraction. You can write this also as 30h minus 11 by 2 m. So this is the generalized formula we have for finding the angle between. Otherwise we will have to draw the clock every time and find the answer. It will be difficult with this formula and we will be able to solve the problems easily. Clear of this formula again? Yes? Okay. Next, you will see The coincidence of hands. What do you mean by coincidence? Coincidence. Put it together. Yes. Vowel. Can you tell me what point where coincidence happens? Anytime. 12 o'clock. Minute hand and arm and top of one another. That is their coinciding. Okay. So we have one example is 12. Okay. When does the up and next coincide? Now after 12, then 1, 5. Then 2, 10. Then 3, 15. Then 4, 20. Then 5, 25. Then 6, 30. Okay. So what is 6:30 like? 6:30 will actually look like this. So our assumption is not that. It's not just 1 hour 5 minutes, 1 hour 5 minutes. We are missing something because 6 and 6:30 it is a little bit ahead. Okay. So we need to find out what time is. Now you noted this formula, right? So okay, imagine a clock. Time is 11 a.m. 11 a.m. to 1 p.m. 11 a.m. to 1 p.m. Okay. So this is the duration of 2 hours. Okay. 11 a.m. to 1 p.m. Imagine the clock at 11. It's moving ahead. 12, 1. How many times does the hour hand and the minute hand coincide? Starting at 11 a.m. Imagine the clock 11, 1, 12, 1. How many times does it coincide? It coincides once. Because it starts at 11, then it coincides at 12, then it comes to 1. But to coincide after 1, it needs to move past 1. It needs to go to 1, 5, something after 1, 5. So it only coincides once. At 12 o'clock, it only coincides once. Okay. So we have coincidence of 1 time. Now it will be 1 p.m. and 11 p.m. Period of 10 hours. How many times does it coincide? Starts with 1. So 1 sometime after 1:05, then after 2:10, then 3:15, 4:20, sometime after 5:25, sometimes after 6:30, sometime after 7, sometime after 8, also sometime after 9, sometime after 10. It will coincide. So till 11 p.m. it will coincide 10 times. Every hour it coincides at least once. So we will have 10 times it coincides. Okay. So 11 a.m. to 11 p.m. It's a period of 12 hours. 11 a.m. to 11 p.m. it is 12 hours. In 12 hours we have 10 plus 1. 11 times the hands will coincide. Remember, 12 times it won't coincide 12 times. In 12 hours it will coincide 11 times. 12 hours, 11 times it will coincide. So, for 11 times it takes 12 hours. So 11 times coincidence it takes 12 hours. So, for one time, coincidence, what's the time it takes? 12 by 11. 12 by 11 hours. This 12 by 11 hours is 1 hour, 5 minutes, 5 by 11 of a minute. This 12 by 11 is 1 hour, 5 minutes, 5 by 11 of a minute or 65 5 by 11 minutes. This is the time it takes for the clock to coincide. This is the time it takes for the clock to coincide once. From 12, then 1 hour, 5 minutes, 5 by 11. So, after 12, it will coincide after 1 hour, 5 minutes, 5 by 11. So, it's not actually 1 5. It's actually coincide at 1 5, 5 by 11. But we are not actually seeing the 5 by 11 because it's not a full minute. So, we assume that it is 1 5. Then, move on to the next. Plus 1 hour, 5 minutes. So, 1 5 2, 10, 5 by 11 plus 5 by 11, 10 by 11. So we have 2, 10, 10 by 11. Again, 1 full minute is not completed, we don't see much difference. Next, 1 hour, 5 minutes. 3, 15, 5 by 11. That is 15 by 11. 15 by 11 is an improper fraction. So we reduce it into 11 by 11 plus 4 by 11. So we have 15 by 11 here. We are going to take plus 1 here. So 316, 4 by 11. 316, 4 by 11. So here we see the difference. It's not at 315, it's actually at 316 and sometimes past 316. Unfortunately, it will come to 4, 21, 9 by 11. It will go at sometime after 6:30. It will actually have coincidence. It will not be at 6:30. It will be at 6:32 or 6:33. That time it will be coincident. So this is how we get the times of coincidence. It's not 1 hour 5 minutes. It's 1 hour 5 minutes 5 by 11. This 5 by 11 is what we were missing first. That's why we got the wrong answer at 6:30. Clear? 1 hour 5 minutes and 5 by 11. Okay, the clock is starting from 12 o'clock and find the time of its coincidence between 7 p.m. and 8 p.m. Find the time of coincidence between 7 p.m. and 8 p.m. Find the time of coincidence between 7 p.m. and 8 p.m. Between 7 and 8. So it should be 7 hours. 7. Something should come in. So multiply this by 7. Between 7 and 8. So the coincidence will definitely happen beginning with 7. So multiply this by 7. So 7. 7 into 5 is 35. 7 into 5 again 35 by 11. So 11 into 3 33. 11 will go 3 times in 35. So this will be 7, 35 plus 3, 38. Remainder is 2 by 11. 7, 38, 2 by 11 is the time when we have the coincidence. 180 formation. 180 formation by clock stands. So when does the clock stand for 180 degree? Give me one example. 12:30. 6. At 6, clock stand is exactly at 180 degrees. Okay, so we are going to see how many times it happens. Okay, so between 5 a.m. and 7 a.m. Imagine 5 a.m. and 7 a.m. How many times does 180 degree happen? Starts at 5, comes at 6, 180 degree, comes at 7, but it has to pass 7 in order to get to 180 degree. So just once. So it will happen only once. Now 7 a.m. to 5 p.m. 7 a.m. Sometime after 7:05 it will coincide. Sometime after 8:10, sometime after 9:15. Again this will happen. So it will happen 7 a.m. to 5 p.m. 5 p.m. 7 to 12. This is 5 hours. 12 to 5. Again there is 5 hours. This is not a period of 10 hours. 10 hours it will coincide 10 times. Just like the previous one. Okay, so it will coincide 12. In 12 hours it will coincide how many times? 11 times. 12 hours it will coincide 11 times. Same as the previous one. Okay, so again we will have the same interval. 1 hour, 5 minutes, 5 by 11. So our coincidence will be happening at 6 p.m. Okay, so if we are representing it, it will be 6, then it will be the next 1 hour, 5 minutes, 5 by 11. 7, 5, 5 by 11. Next will be 8, 10, 10 by 11. It will be 9, 16, 4 by 11. Like that, it will go 1 hour, 5 minutes, 5 by 11. 1 hour, 5 minutes, 5 by 11. So, same as when we are asked how many times 180 degree forms, it is the same answer as coincidence. There will be 11 times in 12 hours. If you are asked any other angle, like how many times will 90 degree happen, it will be the exact double of the 180 degree, because coincidence can happen only once. 90 degree can be formed in two ways. Between the hour hand and minute hand, then again between the minute hand and the hour hand. So their frequency will be exactly double as that of this one. So they will happen 22 times in 12 hours. This was happening 11 times in 12 hours. They will happen 22 times in 12 hours. Okay, so if you are asked a question like that, that is the number of times that will happen. Okay, clear? There are two clocks. Now two clocks are set right at 12 a.m. Two clocks are set right at 12 a.m. And one of the clock is correct. One of the clock is correct, shows correct time. But the another clock has a problem. That is, it gains 5 minutes for every hour. It gains 5 minutes for every hour. So every hour it will show extra 5 minutes. It will take extra 5 minutes. Okay. So now the time of the incorrect clock is shown as 11 a.m. Time on the incorrect clock is shown as the 11 a.m. What is the actual time? What is the actual time? Okay, so these are the correct and incorrect type of clock questions that we will be dealing with. So first, just make a box, correct and incorrect. Okay, so incorrect clock, 60 minutes will be exactly 60 minutes. In the incorrect clock, 60 minutes will be actually shown as 65 minutes because it gains 5 minutes. Okay. Now we take the ratio 60 is to 65. That will be divided by 5 will be 12 is to 13. Will be 12 is to 13. Okay. So the incorrect clock is actually showing the time of 11 a.m. 11 a.m. means for incorrect clock 11 hours has passed. So just take the ratio between them. That is, we actually want to find the time shown in the correct clock. We don't know this quantity, we denote it as x. So x divided by correct clock ratio is 12 equal to incorrect clock time. That is 11 hours divided by correct clock ratio